हेलो, गुड मॉर्निंग एवरीवन। चलिए, मेरा आवाज़ आ रहा है आप तक सभी तक? जस्ट लेट मी नो इन द कमेंट बॉक्स आई एम ऑडिबल प्रॉपरली टू ऑल ऑफ यू, एंड शैल वी स्टार्ट द सेशन? तो चलो बच्चों, स्टार्ट करते सेशन। So before we go ahead, there are few announcements regarding the CSIR net Maharashtra state. Let's try to look at those announcements. तो हमारा जो 70% फ्लैट ऑफ चल रहा है, ठीक है? सो यू कैन ग्रैब इट फॉर दिस बैच 22nd of October. Okay, if you are interested, then go and enroll for these batches with this 70% flat off. So on the occasion of Diwali, we are offering this. Okay, and also there is a batch launching on the 22nd of October, and batches of Maharashtra set exclusive online course for mathematical science. This is also starting from 22nd of October, and these are our results. Okay, we don't speak, our results speak. So if you are interested for Maharashtra set, definitely you can grab the same 70% flat off on this Maharashtra set course, and the promo code you have to use IFAS. Okay, ITIHAAS. So today's session is based on Cauchy theory. Okay, the Cauchy theory is one of the biggest milestone. Okay, because one of the biggest breakthrough in the development of the complex analysis. So what is Cauchy theory? First understand. Okay, first we'll understand what is Cauchy theory, then we'll try to look at different problems based on Cauchy theory. Okay, so let me know in the comment box, all of you are ready? Every students, you have to tell me whether you are ready or not for this. Just let me know in the comment box, all of you are ready or not. All of you know what is Cauchy theory. So Cauchy theory basically consists of two results, Cauchy theorem and Cauchy integral formula. Okay, if you know both the results, then you can solve any problem based on the Cauchy theory. Okay, so first try to recollect all those results, all those statements. Okay, so let me tell you one results or Cauchy theory. What is Cauchy theory? So it has Cauchy theorem and it has Cauchy integral formula. Okay, so what Cauchy theorem says, if at all we have analytic function, then on the closed contour integral becomes 0. This is Cauchy theory. So if f is analytic on some domain D, then integral over closed curve fz dz becomes 0 for every closed curve C inside domain. This is our Cauchy theorem. Now what is Cauchy integral formula? So Cauchy integral formula, again very beautiful formula. Suppose if is f is analytic, then integral over curve, closed curve again, fz upon z minus a dz is nothing but 2 pi I f at a. Okay, again C is a closed curve, inside domain. So let me know in the comment box, students, all of you understood both the results, because this is very important theory, okay, and this is considered to be one of the greatest milestone in development of complex analysis, okay. So let me know whether you understood Cauchy theory or not. Now you will see how helpful is this, okay, how helpful Cauchy theory is to solve the complex integration, okay. So you will see, you will come across various integrals in which we do not actually integrate the function, we use different results, we use different tools to integrate the function. For example, sometimes we use singularity, sometimes we use residue, sometimes we use number of zeros and number of poles. So these are the tools available to integrate the function. We don't actually integrate the function, we just take help of the tools to evaluate the integrals. All of you are ready for this? So let me know in the comment box whether all of you are ready. All of you got this? All of you are ready for this? So students, let me know in the comment box whether this result is clear to you, this theory is clear to you. Superb. So now we are going to look at what is the problems based on there is one more interesting extension of this, okay, I would like to mention it here. So suppose if you have, let's say, higher power in the denominator, instead of z minus a, suppose we have higher power, let's say we have n plus 1, then this is nothing but 2 pi I upon n factorial, n as the derivative at point A, and this is our extension formula for function. All of you understood? Okay. Prakash Naik हमारे साथ जुड़ चुके हैं. Hello Prakash. All of you understood the Cauchy theory and this extension. This is called as extended Cauchy integral formula. Extended Cauchy integral formula. Okay, students, and this is very interesting formula, students. We are going to use it in the various problems. So let's try to look at one interesting problem here. Fz is, if it is given to be analytic function, then which of the following must not be analytic? Now can you say fz is analytic, then f double dash is also analytic? This is based on yesterday's lecture, analytic function, okay. So first let's try to do this question, and you tell me in the comment box which of the following is going to be not be analytic. If f is analytic, then what will be its derivative? F dash will be also analytic, its f double dash will be also analytic, and so on, okay. In fact, in general, nth derivative will be also analytic. So this is going to be analytic, so but we want not analytic, so this is incorrect. Can this function 1 upon fz be analytic? Let me know in the comment box. Can you say f of z reciprocal of f of z will be also analytic? Can it be true, students? Just let me know in the comment box. Can it be true? Yes or no? Yes or no? No, because for example, counter example, I'm giving you counter example. Let's take fz equals to z. This is clearly analytic function. Then what is 1 upon fz? 1 upon fz will be 1 upon z, and clearly this is not analytic because it carries singularity. So therefore this is not true. This is not analytic, but we are interested in not analytic function. Can you say integration of function is also analytic? Can you say integration is also analytic? Yes, because if function is analytic, then definitely integration exists. So for example, f is analytic means what? F is differentiable. So let's say f dash of z exists, let's call it gz. Then what will happen? Integration fz dz will be what? This is nothing but g of z, okay, because integration of, if I integrate this function, this is nothing but integration of gz, and differentiation definitely exists. So if f is analytic, its derivative and integration both are also analytic, but we want non-analytic function. So therefore option number C is also incorrect. Can you say f of z by 4 is analytic? If f is analytic, then can you say f of z by 4 is also analytic? So in generally, if fz is analytic, can you say fz into a is also analytic? This is the question. Yes or no? If f is analytic, then can you say f of a into z is also analytic? Yes, a equals to 1 by 4. This is also analytic. You can check it by Cauchy-Riemann equations, okay, that we have studied yesterday. So this is incorrect. So what are the correct option? Only B option is correct. Only B will be correct. Everybody understood? Yes or no? Superb. So now let's try to go ahead and talk about one more question. Okay, so this question is based on basically Cauchy integral formula that we have just studied. 1 upon 2 pi I integration sin z upon z minus 5 raised to n plus 1 dz. And what is this integration? For every n, can it be cos 5? For every n belongs to, let's say, naturals. Can every for n equals to 1, cos I become cos 5. For infinitely many values of n, can I become cos 5, and can I become cos 5 for no value of n? So let's check it one by one. Solution. The first thing, we have given I as 1 upon twice pi I integral over c sin z upon z minus 5 n plus 1 dz. ओके, गुड मॉर्निंग राकेश कोहली सेट्टी हमारे साथ जुड़ चुके हैं. हेलो राकेश. So let's try to do this question, students. So we have this beautiful integral sin z upon z minus 5 to the power n plus 1, and we have 2 pi I outside. Now understand what was the formula for Cauchy integral extension. Z minus a raised to n plus 1. This was nothing but 2 pi I upon n factorial, nth derivative at a. So we can take this 2 pi I in the denominator. So instead of 2 pi I will have 1 now. Okay, this is actually our 1. Okay, so what will be the formula by using this? 1 upon, this is actually 1 upon n factorial. So this is n factorial and nth derivative of sine at a, means at 5. So now this is our actually I. So let's try to look at the values. Suppose, can I become cos 5 for every n? No, because if I take n equals to 1, so it will be what? 1 upon 1 factorial, first derivative of f at 5. So what is the first derivative of sine? Cos. First derivative of sine is cos. And which point? At 5. So this is simply cos 5. So n equals to 1. For n equals to 1, I is cos 5. What is n equals to 2? Value of I for n equals to 2 is I equals to 1 upon 2 factorial, which is 2. What is the second derivative? Second derivative of function at 5. First derivative of sine is cos, second derivative is minus sine. So this is actually minus sine of 5 upon 2. So for n equals to 2, we are getting minus sine 5 by 2. So can you say that cos 5, I is cos 5 for every n? No, because whenever n is 2, I is different, and therefore first option is incorrect, second will be correct. For n equals to 1, but can this true for only n equals to 1? Yes, because if my n is increased, the factorial terms will be there. It is, suppose if I take n equal to 3, it will be 3 factorial. If I take n equal to 4, I will have 4 factorial. So cos phi is only for n equals to 1, not for any other values. Okay, students? Okay. Now can you say cos phi I is cos phi for infinitely value of n? No, because cos I is cos phi only for n equals to 1. So this is incorrect. Can you say I is cos phi for no value of n? This is also incorrect, because for n equals to 1 we are getting I is cos phi. So answer will be only B correct. You see, this is very beautiful question, and we have used it for extension. Okay, we have used it for cos Cauchy extension formula. Understood, everybody? Just let me know in the comment box whether I have got this question or not. All of you got it? Good morning, Umesh, Rakesh, Nishi, Ashutosh, Sujata, Shetty, Prakash. Very good morning to all of you. So students, on the same line, try to work for the next question. This is our next question. Integration of a real part of z over gamma. Gamma is our ellipse. Gamma is our ellipse. So how one can do this? Gamma is our ellipse. Yes or no, students? Okay, so try to solve this. Actually, integration is our over gamma. A real part of z is always x dz. So this is what actually we have to integrate. Try this question. This is very interesting question, and you will be very happy after solving this question. Okay, because these questions need patience. Okay, this kind of questions need patience. These questions need efforts. Okay, and then we'll get that satisfaction after getting the solution. Okay, so this is very important. So let's see who is able to do it correctly. Even if you don't get the answer, okay, at least you should try. So let's try this. Some hint. Okay, so I'm giving you a hint. Try to parameterize this ellipse first. Okay, what is the parameterization of ellipse? X equals to a cos x equal to a cos t, or you can take theta here, doesn't matter, or y equals to b sin theta. This is the parameterization. So our z will become x plus iy. So x is a cos theta plus I b sin theta. All of you know this is the parameterization of the ellipse. Why? Because if you take x by a, it is cos. If you take y by b, it is sin. Just square and add both sides. So you will get x square upon a square equal to cos square, y square upon b square, sin square. Add both of them. So I will get x square upon a square plus y square upon b square equals to 1, and this is nothing but, students, our ellipse, and therefore this transformation is correct. This parameterization is correct. Okay, so this is the hint I have given you. You get z, just differentiate, you will get dz also. Okay, after getting dz, replace x and dz and just integrate theta. For this ellipse, theta goes from 0 to 2 pi, so theta goes from 0 to 2 pi. Everything I have given you in the hint, just try to look at the calculation. Okay, Rakesh, hopefully all of you understood this hint. Good morning. Okay, so what is dz? Dz will be a, get derivative of cos is minus sine d theta, plus I, b, sine derivative is cos theta d theta. We are taking d theta common from both the factors. Now our integration is x is what? X is a cos theta. What is dz? Dz is minus a sin theta plus I, b, cos theta d theta. What is theta? 0 to 2 pi. Okay students, 0 to 2 pi. A into minus a will be minus a square, sin into cos plus a cos theta into b cos theta will be ab cos square theta, and this I is also there into d theta. Up till here it is clear to everybody? Up till here, is there any problem? Do you have any difficulty in understanding any step? Let me know in the comment box. I will repeat again. If anyone have any problem in any step, let me know. I will repeat again. Okay, don't hesitate. Okay, so just integrate on both sides, you will get the answer. So if I adjust 2 in numerator and denominator, I will get this as sin 2 theta. This is minus a square by 2, minus a square by 2. This is sin 2 theta, sin 2 theta, integration over 0 to 2 pi d theta, plus this is IAB, integration 0 to 2 pi cos square theta d theta. Now understand this sin 2 theta derivative is what? Cos 2 theta. Cos 2 theta upon 2, and over this limit this will be 0. So if you want to understand, this is minus a square by 2. What is the integration of sin cos minus cos 2 theta by 2? So this will become 4 over 0 to 2 pi, plus we have IAB outside, IAB outside 0 to 2 pi, and we have this cos square. Cos square means 1 plus cos 2 theta by 2 d theta. This integral cos 4 pi is 1, minus cos 0 is also 1, so this will be directly 0. IAB is outside, and this 2 also you can take outside. So what is integration of 1? Theta. What is integration of cos? Sin 2 theta by 2 over 0 to 2 pi. This is IAB by 2. This is 2 pi. Sin 2 pi is 1 by 2. Lower limit is 0. And sin, this is going to be sin 4 pi, this is 0, and sin 0 is also 0. So I will get this 2 and 2 cancel with each other. So I will have IAB into pi. So this is the answer. Let's check the options, whether this answer is there in option or not. So IAB and pi. Let's look at this option number B. This is going to be correct. Hopefully all of you understood this question. Okay, Chaitra, आपको किधर डाउट है तो पूछ सकते हैं. If you have any queries, you can ask me. but this is a very interesting problem based on the complex integral. Chaitra, Rakesh, maths master, Prakash, Umesh, Nishi, all of you understood this question, students? Very good. IAB pi is the correct answer. Chaitra, do I understand this question? If you know, just let me which step you didn't understand. You can let me know. Superb, superb. If this question is clear, then you can able to solve any question based on the parameterization, because this was a very interesting. Okay. Next question, calculate the integral I equals to integration mod z equals to 1 equals to mod z minus 1 into mod dz. So let's look at this integration over unit circle, and inside we have mod z minus 1 mod dz. How one can do this? Superb, superb. So next question is again very interesting, and in this question you will have to use, okay, I'm not giving you hint this time, you try by yourself, and if you stuck somewhere, do ask me. Definitely if you're not able to solve it, I will give you a hint. Okay, so first try yourself and you tell me what we can do, or what are the ideas, what are the different ideas. Mod z formula. Okay, try this, whatever approach you can think of, you try this by your approach and see whether you are arriving at the answer. Answers are 8, 4, 8 pi and 4 pi. Okay, these are the answers. Okay, student, so how one can do this? Any idea? Any guess what how one can approach? So see, usually we had dz in this integral formula, but we have mod dz. So whenever we have mod dz, and also look at this circle, we have given mod z equals to 1. This is our circle. So again, you can actually parameterize this in polar form, because whenever we have circle, it is convenient to solve by polar form. Okay, so what is polar form of mod z equals to 1? It is nothing but z equals to r cos theta plus I sin theta, or r e raised to I theta, isn't it? Isn't this where r is equals to 1? So you can check that z is r e raised to I theta. So what is our dz? Dz will be r is equals to 1 because radius of the circle is 1. So we can take 1 here. That means z is e raised to I theta. Dz will be e raised to I theta I d theta. Okay. So this will be our mod z equals to 1 curve C. Okay. Z is e raised to I theta minus 1. Mod dz is what? If I take mod on both sides, it is going to be what? If you take mod on both sides, dz is this. Mod dz is mod I theta is 1. Mod I is also 1. So equals to mod d theta. But theta is what? Positive always. Theta goes from 0 to 2 pi. So this is non-negative, and for non-negative number we can write d theta. Understood why this mod is vanished? Because d theta is non-negative quantity. Okay, and therefore we can eliminate the mod. So dz is actually what? Mod dz is d theta, and theta goes from 0 to 2 pi. Is this clear up till now? Again we have used parametric form. Okay, in previous question also we have used parametric form. In this question also we have used parametric form. So let me know in the comment box how one can solve this further. Now see, we have mod dz. Okay, mod e raised to I theta means what? We can write it as mod cos theta plus I sin theta minus 1. Okay, that means 0 to 2 pi. What is the, this is mod, no? Okay, cos theta minus 1 plus I sin theta. What is the model of this? Square root of real part square minus plus imaginary part square into root of that d theta. Up till now there is any issue? All of you understood this? Just solve this question. After this, everything after this is just about calculation. So this is what? Cos square theta minus 2 cos theta plus 1 plus sin square theta into d theta. Okay, just this cos square and sin square will become 1 and this one will become 2. Okay, so what I'll have 0 to 2 pi 2 minus 2 cos theta d theta, isn't it? This 1 and this 1 will become 2 minus 2 cos theta d theta. You can take root 2 outside, so this will become 0 to 2 pi root 1 minus cos theta d theta. What is root 1 minus cos theta d theta? This is nothing but 2 sin square theta by 2. Again this root 2 we can take outside, so this will become 2 0 to 2 pi, and sin square theta by 2 root is sin theta by 2 d theta. All of you understood up till here? Okay, so this sin theta I can write as, what is integration of sin? Minus cos theta by 2 upon 1 by 2. So this 1 by 2 will go again in numerator, and we have 0 to 2 pi in the limit. So this is minus 4. What is upper limit? 2 pi upon 2 is pi. So cos pi is minus 1, and again lower limit is 0, cos 0. So this is minus 4 minus 1 minus 1. So minus 4 into minus 2 will become plus 8. So, so answer is actually plus 8. So see, it requires patience. Without patience Okay, you cannot achieve anything, and without patience, CSR net is a difficult task. You must have patience. Okay, what happens if questions like this comes in exam? They solve it up till here and they see there is more calculations, so they leave it after this. So you need patience. You have work up till here, just work further, you will get the answer. Okay, but it requires patience. Okay, so which option number is correct? Option number A is correct. Okay, students. Badhiya. What about this? Now this question based on the image of this mod z equals to root 2. Now see this question. Fz is we have given z plus z bar by 3. Then image of the mod z equals to root 3 is what? Ellipse, straight line, hyperbola or circle. Image. So this question is actually based on analytic image of some function over this mod z equals to root 3. What will be the image? So understand this question. We have given this function fz and they have given circle here, root 3 radius circle. Then what will be the image in the codomain? This is the question. What will be the image? Whether it is ellipse, circle, hyperbola, straight line, what will be it? So try this. So how one can do this? Any idea? Answer is circle. Okay, let's check. So we have given fz equals to z plus z bar by 3. Okay, students, and mod z we have given equals to root 3. If I square on both sides, so I will get z bar equals to 3. That means z bar is 3 by z, or 1 upon z bar is z by 3. Okay, or we can write 1 upon z is z bar by 3. Okay, so this is actually z plus, what is z bar by 3? 1 upon z. Now again we have z plus 1 upon z. This is the function, and clearly you can check that if I try to, we have again circle, and I have just told you whenever we have circle, it is very convenient to convert into polar form. What is the polar form of this circle? So polar form of this circle is mod z equals to root 3 is what? Z equals to root 3, or we can say z equals to root 3 e raised to I theta. This is the polar form of this. So if I plug this value of z there, what will be our fz? Fz means u plus ib. What is this? Z is root 3 e raised to I theta plus 1 upon, what is z? Root 3 e raised to I theta, isn't it? So now what we'll do, this is our root 3 e raised to I theta means cos theta plus I sin theta. What is 1 upon root 3 as it is? E raised to I theta will go in numerator, become e raised to minus I theta, which is nothing but conjugate of this. So I can write cos theta minus I sin theta. Now we'll collect the real and imaginary part. Okay students, we'll collect real and imaginary part. What is real part? This is real part. So root 3 plus 1 upon root 3 cos theta plus this root 3 sin theta, and 1 upon root 3 minus I sin theta is root 3 minus 1 upon root 3 sin theta into iota. So if you look at carefully, we got a real and imaginary part. This is our u plus iv. What is real part? This is real part. What is imaginary part? This is imaginary part. Okay students. So next step, we'll collect u is root 3 plus 1 upon root 3 cos theta. V is root 3 minus 1 upon root 3 sin theta. What is u upon root 3 plus 1 upon root 3? This is cos, and v upon root 3 minus 1 upon root 3 sin theta. Now we want equation in terms of UV plane. Okay, we are interested in equation in UV plane. So in UV plane, what happens? Here we have x and y axis, and here we have u and v axis, and we want image in the UV plane. Okay, so there should not be any theta, then any x or y. There should be only terms in u and v. But you see carefully, we have theta in this. So how to eliminate this theta? Just square and add again, just like we have done in previous question. So u square upon root 3 plus 1 upon root 3 whole square plus v square upon root 3 minus 1 upon root 3 whole square is nothing but cos square plus sin square is 1. And what is this question, students? What you can see, isn't this ellipse? Isn't this, students, our beautiful ellipse? And ellipse will be the answer. Where is ellipse? Option number A. Is this question clear to all of you students? Yes or no? Is this question all of you understood? Just let me know in the comment box. If this question is clear, just type CC in the comment box. Okay. So there is one homework problem for you on this. Okay. So on the same line, you try one problem. This question is actually asked in previous year exam, and definitely you will be able to do this question. So let me give you one homework problem. So this is how you for homework. Definitely you try this question and let me know. Okay, so question says, if you are a simple closed curve in complex plane such that dz upon z 1 minus z square is, we have given the integration, then what are the different possible answers? Can it be 0 to plus minus pi I, 0 comma plus minus pi I, 0 comma plus minus pi I, comma 2 pi I, and so on? Last integral is last answer is 0. You have to experiment different curves and try to solve this. You can also solve this question by residue theorem, but residue theorem okay, we have not seen in today's session. Definitely try this question. If you don't get the answer, I will solve it by both the methods in next lecture. Okay, so tomorrow's session is the conclusion session, and we are going to have complex integration, different complex integration, in which we will see residue theorem, argument principle. This everything is going to become. Okay, so definitely try this question and let me know the answers tomorrow. Okay, so this is all for today's session. Thank you for joining, everyone. If you have any queries regarding this session, this series, you can ask me. Okay, if you have any queries, any doubts in today's session, you can ask me. Okay, if not, definitely we'll wrap this session here. Okay, so Rakesh is asking what is the hint for this question. So hint is to try to look at different curves in a place. Suppose I'm looking at, let's say, dz z1 minus z square. First you try to identify the singularities. Singularity will be 0, 1 or minus 1. So now you try to look at, suppose I'm taking, let's say, circle with radius, say 1 by 2.5. Okay, clearly 0 is the only singularity. The rest two this factor will lie outside. Well, answer will be what? For this 1 minus z square, z is in denominator. The answer is 2 pi I into f at 0. The answer is 2 pi I. Okay, if I change the rotation, it will be minus 2 pi I. So plus 2 pi I and minus 2 pi are the possibilities. So this will be directly discarded. This will be directly discarded. Similarly, you vary your curve. Suppose I'm taking, let's say, 3 by 2. Then you will have 1, 0 and minus 1 all lies inside. Then you will get different answer. Then you try z mod z equals to 2. So you experiment with different values. Okay, different values of radius, and check what are the different possible answers, and you can discard the remaining option. Simply you can see that this is the, I'm giving you answer as well. This will be the correct answer. Option number C is the correct answer. You experiment this, will you itself by yourself you can check this C will be correct. Okay, hopefully this hint is enough for you and you will able to do it. This is all for today's session. Thank you for joining.